Today we're going to take a look at a percent abundance problem, where we are given the mass of two stable forms of silver along with the average mass, and we're tasked with finding the percent abundance of one of these isotopes. So these problems are relatively straightforward once you know the overall format of how to work with them. So to start, we know the average mass of 107.87. And we know this average mass is going to be made up of these two stable forms of 106.9 atomic mass units and the other of 108.9 atomic mass units. However, the way we can relate these is by multiplying them by their percent abundance. So this will be x. And this will be 1 minus x. So the reason that we use 1 minus x and not a different variable here is because we know that all of these should add up to 1, because we are finding the average here. So now we can rewrite this in looking for x. (106.90x) plus, and distributing here, now we have everything written out and expanded as we need. It's just a little bit of algebra here to isolate everything to one side. So let's do that now. So we'll bring this over to this side, and we'll do just a little bit of math to subtract this from here. Now all we have to do is simplify each side. And solve for x. And here we can see that x should equal 0.515 or 51.5%. Now we can verify this by plugging it back into our original equation up here. So let's do that now. Now all we have to do is simply sub in for x. We get an answer of 107.87 AMU, which, comparing back from the beginning, is the average mass that we had initially. So that means that this is the correct answer for x, which is going to be the percent abundance for this first isotope. To find the second isotope, we simply have to go 1 minus x, x being 0.515, and this would yield a result of 0.485 or 48.5%.